So when last we left acids, we were looking at the 8 ions, and do you remember the little mnemonic or memory device that we use to remember what 8 ions get called? I ate something icky. So if we have dichromate, then we end up with dichromic acid. Yes? So 8 is ick. What kind of ion gives you the hydroic? What kind of ion gives you a hydroic? Yeah, that's our ide ion. Okay, my ride has hydraulics, if you remember that. So if we had HCl, that would be chloride. We would have hydrochloric acid. And do you remember there were 2 elements that gave us something a little bit funny? What were those 2 things that were a little bit funny? Sulfur and phosphorus. So it's the same thing with sulfate and sulfite. Normally, we would say sulfic acid, right? Because it's a sulfate, sulfic acid, but that would be wrong. With sulfur, you need to have an in there, sulfuric acid. Sulfur and phosphorus need the extra syllable. Isn't that fantastic? I know, right? And phosphor. Now, the nice thing is sometimes people are like, is it sulfur or is it phosphor? The U goes with the U. Sulfur needs 2 U's and phosphor needs 2 O's. That might help you remember it. Okay? Now, we need to talk about organic acids because organic acids are kind of funny. Organic compounds, do you guys know what organic compounds are based on? Carbon. So organic is based on carbon. And still, there's nothing different about naming them. The 8 ions still become ic acids. Nothing new there. The only thing that is weird is that we write the anion first. So we have CH3COO minus and then we have the H plus. That's odd, yes? Strange. However, that's just how it is. Ravina, could you close the door for us, please? There's a bunch of chit-chatting out in the hallway. Thank you so much. Pardon me? Well, there is the other class too. I should just go in and yell at everybody. Ah! Okay, so do you guys care about why it's like this, or do you not care? You'd like to know why? Okay, so what it is it's because the structure of these acids, like let's say we took acetic acid for starters, you have a carbon with 3 hydrogens attached. Okay, so we're just drawing the Lewis structure for acetic acid here. The carbon is attached to another carbon. There is a double bond to an O. and a single bond to a second O, and then a bond to an H. The acetic acid can't have a resonance structure. The acetate ion can, because the ion would look like this. So that would be the negative ion, and you could have resonance where, you know, this one moved over here and so on. Yes? So yeah, you could have resonance for the ion. But because this one's already filled up, we can't really have resonance here. Okay. So that is our structure, and we usually tend to put, this is what we call an organic functional group. You don't need to know this for this year. I'm not going to go into organic chemistry much. But a functional group is something that appears in chemistry often. Okay? Are you guys familiar with amino acids? Have you heard of those? The acid part of an amino acid is this group, a COOH, the COO group. COO. Okay? So every time you hear an amino acid, you know it contains one of these organic acids. It also contains an amine group, which we might learn about a little bit later. Okay? So this group here is what makes it acidic. We usually write functional groups on the ends of our carbon chains. And so that's why it goes on the end. Now, when this thing... He had his hand up before you, actually, to be honest. So do you remember how when salt dissolved in water, what happened to salt when it dissolved in water? We had an Na, and it was bonded to a Cl, and they were stuck together. But then when we put it into water, those two ions, what did they do? They separated, yes. Acids work in the same way, okay? And when an acid dissociates in the water, you will have an H plus, and then you'll have the CH3COO minus ion, and they will be separated. So when we look at this structure, it is always the hydrogen that is on the COO, the COO group, that is the one that dissociates in the water. We call it the acidic hydrogen. Technically, you don't need to know any of this for this unit, okay? You just need to be able to recognize that if you have COOH, that means you have an acid. And so you should name it accordingly, okay? So you don't need to know any of that stuff about how it dissociates or what the structure looks like, anything like that. Just know that the COO group, COOH, means you have an acid. And when you're looking for the anion is at the front, which is weird, okay? So you're going to be like, what is the HCOO minus ion? You can go look that one up. That is formate. Now, in terms of the ions, if you look on your regular table of ions, you're like, hey, I don't see any formate. There's no HCOO. And that is why you have the anions for acids because it gives you a much more extensive list of acids. So for example, these ones are arranged alphabetically. So this is on page 3. So you can see we have formate is listed here. If you find the alphabetical listing is not too useful, which sometimes it isn't, you can always look at the anions which are organized by charge. So you can say, oh look, I have all my organic ions are down here, right? So I can look and find out what they're named. And I've kind of tried to group them by element. So you can find all of your bromines are all together, bromate, hypobromite, bromate, perbromate. Okay, so those are all grouped together to make them easier to find. So pages 3 and 4 on your little handout there, that will be useful for the acid test. Are you allowed to use the list of acids to do your acid quiz? No. Okay. If you're going to, if you're tempted to use that, I can give you a copy of the booklet that does not have the list of acids, but do not use the list of acids. I actually should not have put it in the handout, but there we are. Look, oranges. Go get an orange. Quiz 12 is available, by the way. Manning? Quiz 12 is now up and running whenever you're ready for it. There's only 2 versions of it so far. No. Quiz 12. But we're not there yet, right? I was thinking maybe Monday. How about Tuesday? Yeah? Tuesday? I mean, the other option would be this Friday, but I feel like that's too soon. Tuesday's good? Test on what? On all of this. What? It's not crazy. It's all review except for the acids and the hydrates. You've done it for 2 years already, right? Yeah. Even if you don't remember any of it, I've taught it to you again. Yeah. Yeah. Okay. So that is how you name your acids. Okay? Last group of acids is our ite ions, and ite ions become us acids. So we have chlorite becomes chlorus acid. Hypochlorite becomes hypochlorous acid. And I want you to take note here, this is OUS, not US. Okay? Us, but not us. It's OUS, not just US. Okay, so chlorus, not chlorus. And once again, I'm going to remind you, who are the 2 weird ones that have 3 syllables? Sulfur and phosphorus. Sulfurous and phosphorus. Okay? I will also, should we just do a very quick thing of how to write the formulas? And then I can just send you on your way to do practice and stuff? Okay, this is page 83. what you need to know is that the hydrogen ion is H+. Okay? Super hard, right? Hydrogen is H+. And you're always going to be combining H+ with whatever the ion is. What's that? Are we good? Okay. Yeah, we're on page 83. The total positive charge has to equal the total negative charge, just like all other formulas, okay? Except for the covalent ones where you just have to use your prefixes to tell you how many of each. So you look at this and you say, I have hydrobromic. That tells me that my ion is an ide, because my ride has hydral X. So I have bromide, which I know is Br minus. So I take my H plus and my Br minus, and I say, do my charges balance? Yes, they do. So I just have to write HBr, and that is it. That is hydrobromic acid. Hydrosulfuric, again, that would be an ide ion, sulfide, S2 minus. If we take an H plus and we put it together with an S2 minus, do I need more of any ion? Yeah, I need 2 of the H pluses, so it's going to be H2S. And every once in a while, you're going to come across hydrocyanic acid. That's from cyanide, and you should remember that cyanide is a polyatomic ion. So you will actually need to look up cyanide unless you happen to know it by heart. So you're going to say, okay, I've got H plus, and I have Cn minus. Oh, I don't even need to do anything. I just write HCN. Yeah? Hydrophosphoric acid. This is just to prove that you can do it with a 3 negative ion. Phosphide is 3 minus, so you need 3 H's. If anyone is interested, this is what we call a triprotic acid. That's like part of grade 12. It's called triprotic because what is an H plus ion? An H atom, we have a proton in the nucleus and we have an electron around the outside. What happens when we have an H plus ion? What do we have left? Just have the proton left. So H plus in grade 12 will be referred to often as a proton. And so this is a triprotic acid because it has 3 protons. This would be a monoprotic acid because it only has 1. And this would be a diprotic acid because it has 2. But you don't need to know that. That's grade 12. I don't even know why I mentioned it. I just got excited for a minute. I'm sorry. Okay. All right. We still remember that ick, I ate something icky. So if you have bromic acid, there's no hydro at the front. So that means it's made from bromate. And when you have an 8 ion, that means it's a polyatomic ion, and you look it up on your chart. And bromate is BrO3 minus. And this is where you might want to use the alphabetical list. Yes, Micah. You get the first page, and you get page 1, 3, and 4. You don't get that second page, which is like the list of acids. Okay? Yeah. So when you're doing your quiz, you're just on the honor system not to use it, because obviously on the test I'm going to give you one that doesn't have it. Okay? Yeah. So we look it up, it is BrO minus. We say I have an H plus, I have a BrO3. So my formula is then HBrO3. Nobody's looking at what I'm writing. Am I right? What's wrong with what I've written? I wrote brackets. There should not be brackets unless I have more than one of that ion. Okay. Sulfuric acid, ic, goes with H. So we have H, we have SO4 2 minus. That means we need 2 of the H pluses to give us a 2 plus charge. So that's going to be H2SO4. That is a diprotic acid. I'm just going to keep saying it because I can. Cyanic acid is made from the cyanate ion, which you will not find on your normal table, I don't think, but you will find it on your expanded table of anions for acids. Okay. Phosphoric acid is made from the phosphate ion. There we go. Organic acids. The only thing that's different is where do you put the H? At the end. Okay? Put the H at the end. These are all monoprotic. So that means there's only going to be one H. So basically you just take your anion and you put an H on the end of it. You take your anion CH3COO and put an H on the end. Take benzoate ion and put an H on the end. And finally, there's some us acids. I don't know that there's much more to it. You just go, oh, it's an us acid, therefore it's an ite ion, and you look it up. And then put however many hydrogens are needed to balance the negative charge. Is good? You guys can carry on at this point? Yes? I don't know which quizzes people are on because I left my marks book at home, which was really stupid, so I've made a new sheet here. So I'm just kind of trusting you to kind of know approximately where you're at. I'll have it next day, just in case you missed something. So we're going to be finished this unit Friday. So you'll want to be all done your quizzes by Friday. All right? You can review over the weekend, review on Monday. Our test will be on Tuesday. Okay? But we're moving on Monday. We're doing other stuff. Yes. Hello.
Hi.
Carbonate, hydrate, and aluminum phosphate monohydrate. Yay!
Perfect.
And you have a choice at this point as to what you want to do.
Okay.
There is enriched material if you want to learn a little bit of organics, or you can start reviewing. Do you have a preference?
Not really.
Okay, I'm going to give you both,
Okay.
and then you can decide,
Perfect.
okay? Yeah. In pages 75 and 76, there's like a million questions of all different types. Yeah. Okay? Yeah. So, yep. Oh, and you get this back, of course. There you go. Thank you.
Wait, but isn't it one element? Cyanide?
Cyanide, no. It's a polyatomic physics because it's got two capital letters.
So it has to be
And it has that "ide" ending, which makes it sound like an element, but it's not because it's on that. Yeah. Okay. This one looks good though. Okie dokie.
Consistent fives. Wait, so anything on this? So if it's like a plural on this list, then it automatically gets a bracket?
Only if there's more than one of them.
Only one, okay.
So if there's if it's like sodium cyanide, NaCN, then it's just no brackets.
Kind of like the non-metals, right? Or just the general elements on the element table, like phosphorus. Potassium 4 is like there's no brackets, right?
There's no brackets.
And I thought that implied that.
Yeah, yeah. No, unfortunately, no.
Right.
Yeah.